Welcome back to A-Star Science, our GCSE must-know chemistry series. Today we're going to be talking about oxidation and reduction. If you want to learn more about oxidation reduction, you can watch my video on half equations where I go into oxidation and reduction in regards to half equations, electrolysis, a bit more in depth. So oxidation reduction has two definitions in chemistry. Let's look at the first one. Oxidation means adding oxygen, to an atom or to an element. So for example, if I have carbon plus oxygen, I can form carbon dioxide. So here the carbon has been oxidized, and we use that term. The carbon has been oxidized because we've added oxygen to it. Now reduction just means the opposite. So reduction means the removal of oxygen. So for example, if I take iron oxide, I can use carbon to actually remove the oxygen, and I'm going to get iron back plus carbon dioxide. Now this isn't balanced. I think I can balance it very quickly. I'm going to put a 3 here in front of the carbon dioxide. That means I need 6 oxygens. So I'm going to put a 2 here, put a 4 here, and put a 3 here. And I think that's balanced now. Let me just move this plus sign. Okay. So iron oxide has been reduced. We say reduced. Why? Because oxygen has been removed from the iron oxide to form just iron all by itself. And this is really important in industry when we have ores found in nature with metals in them. A lot of times they have oxygen attached to it, and we need to use this process to get the pure metal out. So in this case, carbon has been used to reduce iron oxide. So those are the first definitions. That's definition 1 in chemistry. There's another definition that's really important as well in chemistry for oxidation and reduction. Let's talk about that now. So oxidation can also stand for the loss of electrons. Oxidation can stand for the loss of electrons. And we often see this in a little acronym, which I'll introduce a bit later. And reduction stands for the gain of electrons. And that acronym you'll see used in chemistry a lot is oil rig. Oil rig. Oxidation, that's the O, is loss of electrons. Reduction is gain of electrons. So that's a little acronym that you can use to remember what it stands for. Now, how does this apply to what we saw earlier in terms of oxidation and reduction? Well, for example, let's look at if we take iron and I add oxygen to it to form iron oxide, Fe2O3. Here, the iron is a neutral atom, and here the iron now becomes a +3 atom. So how do we go from neutral to +3? We must have lost 3 electrons. We've lost 3 electrons. That means it's been oxidized. And we can see that fills complete both of the definitions. The first definition was adding oxygen, and clearly the iron has had oxygen onto it, as well as we can see that oxidation is loss of electrons, and it's lost electrons there. We can see it's gone from 0 to +3. But now let's look at the oxygen. So if I look now at the oxygen, oxygen here is a neutral molecule, 0 for neutral. And here, the oxygen has become -2 on the periodic table. Look at my video on periodic table and charges if you want to learn more about why it's -2. We know it's -2 very quickly because this is what we call the little switcheroo. If this is a 2 here, that means this must be -2 and this must be +3. So the oxygen was at 0 and now it's at -2. Well, how does that happen? Well, that means we must have added 2 electrons to that neutral oxygen. And that also fulfills both definitions. The oxygen has been reduced, and that shows that it's gain of electrons, okay? It's gained electrons. So there are 2 definitions of oxidation and reduction. Oxidation is loss of electrons. Reduction is gain of electrons. Let's look at one more example. Let's take, for example, sodium plus chlorine. That's going to yield sodium chloride. We can balance it real quickly. We have 2 chlorines, so we need 2 chlorines on the right. That means we also need 2 sodium. Again, atoms are neutral, so the sodium is neutral. And here, this sodium becomes a +1 ion. So to go from 0 to +1, that means it's been oxidized. Okay, it's lost an electron. The chlorine here, it's a chlorine molecule, that means it's neutral and has become a -1 ion. How does it go from 0 to -1? It must gain an electron. That means it's been reduced. Now there's an easy way to remember this, and that is metals, they tend to be oxidized. That means they tend to lose electrons. They tend to be oxidized. Whereas nonmetals gain electrons, particularly that group 6 and 7, which are the halogens, as well as the oxygen group, the group that oxygen is in group 6. And so that's an easy way to remember. If they are metals such as sodium, they tend to be oxidized. And if they are nonmetals such as chlorine, they tend to be reduced. That means they will gain electrons. You can flip this as well, and you see this a lot in A-level chemistry. And it's that what happens then is that metals tend to be good reducers. So we'll call them good reducers. Let's put that over here. Good reducers. Meaning they cause things to gain electrons. And nonmetals like chlorine tend to be good oxidizers. They cause things to lose electrons. But you only really need to understand that when you get to A-level chemistry in some depth. Okay, so that's our video on oxidation reduction. Make sure you like and subscribe. Please do leave a comment below. Let me know what videos you would like me to do, what lessons you would like me to do, and I hope to do it in the future.